So, there we go. Question 1. Which linear equations are in point-slope form? There's more than one correct answer choice. Select all correct answer choices. Okay, so point-slope. I would highly recommend you having this in your notes, or if it's not already. So point-slope. Point-slope is y minus y sub 1 equal to m times x minus x sub 1. Alright, that's our built-in one, so I'm going to be looking for anything that starts with that first. So we have y minus 14 equals 24 times x plus 8. Well, we have y minus the y sub 1 is equal to 24, which is at my m, times x plus 8. Okay, so this plus, that's what is not exactly the same as in our form. However, the way we can have an addition sign in here is if this 8 was negative 8. So they, instead of writing 24 times x minus negative 8, they simplified this minus a negative to an addition. So that is how they have an addition sign there. So that is point-slope form. That one's good. Y plus 8. Again, it has the same concept. So we have a y minus a negative 8 in reality. And they just reduced y minus a negative 8. And they reduced it, the double negative. So equals negative 3 times x minus 7. Okay, that sets up exactly in point-slope. So that one is point-slope. Y minus 11, check, equals 1/5. That's okay to have a fraction as a slope. So far so good. Times x plus 10. Again, this addition is because they subtracted a negative, so that is 1 as well. Y, and then there's nothing here. That's okay still right now, because it could be y minus 0, and you really don't write y minus 0 because y minus 0 is just 0. So far that's still okay, because it could be rewritten as that. Equals 7x. Okay, this is the part that is not okay because we have, we do not have our parentheses. So this one is not in point-slope. Y equals, again, that's still okay because it could be y minus. Where it's not okay is where it's not including parentheses, because there's no parentheses there. So this one's not in point-slope. This one is not in point-slope because we have a negative x plus 12y. Alright, so that's not it. Negative 6x plus y, still not in point-slope. So there's our point-slopes for that. Moving on to problem 3. Okay, which linear equations are in point-slope form? Alright, that's the exact same thing as the first one, so I'm not going to do that. Question 4, consider the graph of the line CD. we have two questions. A, what is the slope of the line CD? And B, what is the equation for CD in point slope form? Okay, select one answer choice for question A and select all the correct answer choices for question B. Okay. So point slope form, we still have the generic equation written up. So let's first find our slope. And that would be our M. M is going to equal, and since they have it graphed out, I'm going to count it on the graph. So slope is the rise, or the vertical distance. So from C to D, it went up 1 unit. So I'm going to say 1. Now, the run is our horizontal distance, and we're going left, so that means it will be negative. And we went left 1, 2, 3, 4. So negative 4. Okay, 1 divided by negative 4 is the same, reduces, or is the same thing as negative 1 divided by 4. So negative 1/4. That is what we're looking for our slope. It's right there. Now select what is the equation for CD in point slope form. Okay, well, here's my slope, so I'm going to use that in the place of M. And I'm going to write two equations because I can write more than two equations, but I'm going to write two right now because they give me 2 points. So I'm first going to write the equation using the coordinates for point C. So the y1 for point C is 1. So if I have my slope as 1/4, negative 1/4, and I use the point C, 2, 1. Alright, the 1 is our y1 and the 2 is our x1. So the equation would be y minus our y1 is 1 equal to m, which is negative 1/4, times x minus x1, which is 2. Okay, so there is one equation in point slope form. Now I'm going to do another equation when we have the slope is still negative 1/4. It didn't change, but the point now is D at negative 2, 2. Okay, so now 2 is our y1 and negative 2 is our x1, and we're going to replace those into our equation form, our general equation. So y minus y1 is 2 equal to my slope, which is negative 1/4, times x minus x1 is negative 2. Okay, so we're going to rewrite the minus and negative 2 as addition. So y minus 2 is equal to negative 1/4 times x plus 2. So there's the second equation I could be looking for. Now we could write many more. I could use this point right here at 6, 0, but I'm not going to because the 2 points that were given are C and D, and so that's the first ones I'm going to look for. Alright, so we have y minus 1 equals negative 1/4 times x minus 2. Alright, there's a point slope form. And then we have y minus 2 equals negative 1/4 times x plus 2. So there we have it. Alright, question 5 is like question 4. Question 6 is like question 4, except that they do not have it graphed out for you. You can graph it out, or you can do the algebra for it. Okay. Question 7. Alright, well, we'll do question 7, where it's not graphed out. Okay, so we're looking again for the slope and the equation in point slope form. Alright. Oh, that was too big. I accidentally erased the M in our general formula. Okay. So we have these 2 points, CD. What is the slope of CD? Okay, well, they are not giving us the graph, so we can do the algebra for it. We can find the vertical distance. So we have labeling first and foremost. Pick which point you want to be first, which point you want to be second. And right now I'm going to have C be the first one, so x1, y1, x2, y2. Alright, and remember we had the rise, which is our vertical distance, and to find distance, we take the difference between 2 values along a number line. And we're just going to take the 2 values that are along the vertical number line, or our y-axis. So we're going to have 0, y2 minus y1. So 0 minus negative 7. And then we have our run, which is our horizontal distance. And so we're going to take the difference along our horizontal line. So we're going to have x2 minus x1. So 4 minus negative 3. Okay, if you notice we have these double negatives on both of them, that changes it to addition. So 0 plus 7 is equal to 7. 4 plus 3 is 7. 7 over 7 is 1. So our slope is 1. Now, what is the equation for the line CD in point slope form? Again, we can have 2 equations right now off the bat because they give us 2 specific points. So if we were to have the slope as 1 and we were going to use the point C, negative 3, negative 7, our equation would be y minus our y1, which is f from our point, so negative 7, is equal to m, our slope of 1, times x minus x1, which is negative 3. Again, we have these double, this minus a negative, so there's our addition. And I'm going to rewrite it as y plus 7 is equal to 1 times x plus 3. Okay, in mathematics, just has a form, when we have 1 times anything, that doesn't change the value of it. So they imply that the 1 is there by not writing it. So we could have just x plus 3. and we would know that the 1 is implied. Okay, so now what if the slope is 1 and we use the point D instead at 4, 0. Alright, we're going to do the same thing. Y minus y1, which is now our 0 because we're using a different point, is equal to our slope, which is 1, times x minus 4. Okay, y minus 0 is just y. And then we have x minus 4. Okay, so now let's look for these two equations. We have y plus 7 is equal to x plus 3. There's our equation number 1. And then we have y equals x minus 4. There's equation number 2. Okay, we're going to do a model. Okay, Constantine is walking laps in this is question 9. Constantine is walking laps in a walkathon to help raise money to cure cancer. One of his sponsors has pledged an initial amount of $1.25 per lap. After 15 laps, the sponsor owes Constantine $30. Which equation in point-slope form models the situation? Okay. We're looking for an initial starting and an ending for, we're looking for a slope, which is going to be, big keyword is per. $1.25 per lap walked. That is a rate. So my slope is $1.25. $1.25, and this is in money per lap, and that gives us a key as to what's our x and y axis. So we have laps right here for our x axis, and we have our money. The laps do not depend on the money. The money depends on how many laps we do. And then it says after 15 laps, the sponsor owes Constantine $30. Well, that's a point. So if I went over 15 on a graph, 15 laps, I should be up at $30 right there. So that is a point. That's a coordinate. So we have 15 laps. And we have $30 that is owed. That's our output. Alright, so now let's write our equation. We have y minus y1, which is 30, is equal to m, which is our slope, which is $1.25. And I'm not writing the dollar signs because we're assuming everything is in dollars, x minus, well, x1, which is 15. Alright, so we have y, we're not, okay, let me rephrase what I said about everything being in dollars. We're assuming the outputs will be in dollars, and so when we write an equation, we don't include any of our units in that equation because it's included on the graphical representation of the equation. So now we are looking for the equation y minus 30 equals 1.25 times x minus 15, which we have right there. Okay, question 10 is question 10 and question 8 are both create a problem. Alright, let's do question 11 then. Sammy has decided to start a stamp collection. His grandfather gives him a large amount of stamps to start his collection, and then Sammy continues collecting stamps at a constant rate. That is a big key indicator that's going to be that is your slope, constant rate. It even says rate. That is what slope is. 3 stamps per month. So our slope is 3, and we have stamps per month. After 10 months, Sammy has a total of 50 stamps. Okay, so we need to figure out which one is going to be our x-coordinate and which one is going to be our y-coordinate. And the rate gives a big indicator of that. Stamps per month. The month is constant. It is our input. We have 1 month at a time. And so that is our x-axis. That is our independent variable. The months do not depend on the stamps or the number of stamps. The number of stamps, though, depends on how many months we've been. So 10 months, 50 stamps. That means we are going to go over 10 up 50. 10 months, 50 stamps. So we have our x and y now. So we have y minus y1, which is 50, equals 3 times x minus 10. There's your equation. Question 14. A grain silo is losing grain from the bottom of the barrel at a rate of 25 pounds per minute. After 8 minutes, there are still 6,400 pounds in the grain silo. Which equation in point-slope form models how many pounds of grain will be in the silo after X minutes? Okay, they tell you right from in that statement which one is going to be your X coordinate in X representation. So it says after X minutes. That means your X-axis is minutes. And then pounds will be our y-axis. And then it says at a rate of 25 pounds per minute. So our slope, again, is right there. The key word is rate, and that is 25 pounds per minute. And my 2 children decided to wake up, so if you hear little noises in the background, that's them playing around this morning. 25 pounds per minute. And again, we see that the X coordinate is in the denominator of our rate, and the Y is in the numerator. And after 8 minutes, there were our 6,400 pounds. So if we were to try and plot that point, it would be 8 and 6,400 minutes. So again, 8 minutes and 6,400 pounds. So there's our points. So we have y minus 6,400 is equal to our slope, 25 times x minus x1, which is 8. Okay, so there's our equation, y minus 6,400 times, oh, quiet for just a minute. Negative 25 times x minus 8. Okay, the reason why it is negative is because they are losing grain. So there's a negative 25. They're not gaining grain. It's not going up per minute. This is going to be going down as the minutes go by because they're losing grain. Alright. So there's a couple of questions thought out for you. And if you have any other questions, please let me know.